So next coming to the layout of the 33 by 11 kV substation. So what are the main components that contains in 33 by 11 kV substation? So 33 by 11 kV means the incoming line is having a voltage of 33 kV, whereas the outcoming or outgoing line is having 11 kV. So from incoming to outgoing, we have the various equipments that are connected in between 33 kV to 11 kV system. So the various equipment or components that are connected from 33 to 11 kV are isolators, circuit breakers, current transformers, and we have the 33 kV bus bar, and we have the transformer, potential transformer, which converts 33 to 11 kV. That 11 kV is giving to the distribution network. This is the schematic or layout diagram of 33 by 11 kV substation. So now we will discuss each equipment or operator that we are using in this substation. So first one is power transformer. So generally the by 33 by 11 kV, which is nothing but it is a three-phase transformer. So the first equipment that we are using in the substation is power transformer. So it is one of the major equipment that is used in the substation. The main function of the transformer is to change the voltage level of electric power. So the power voltage level can be changed through power transformer. It can either step up voltage for transmission or step down voltage for distribution to consumers. So we know that transformers are connected to either step up at from generation to transmission or step down from transmission to distribution. So this power transformers are used in between either generation to transmission or transmission to distribution. It works on the principle of electromagnetic induction, like what ordinary transformer that is based on mutual induction. So it contains the two windings, primary and secondary winding. The electric supply is given to the primary winding, and due to mutual induction, property of mutual induction, the voltage will be induced in the secondary winding through mutual induction. This is the first equipment that we are using in substation. Second one is circuit breaker. The name says that it breaks the circuit when fault occurs. It breaks or it isolates whenever any fault occurs. A circuit breaker is a protective device which is used to interrupt the flow of current during abnormal conditions or during fault conditions, such as any short circuit occurs or any overload occurs. Then the circuit breaker is act as a protecting device, interrupt the fault condition from unfault condition. It can operate automatically or manually. When a fault occurs, the protecting relays send a trip signal to the breaker, causing it to open and isolate the faulty section. So the circuit breaker only isolates and interrupts the supply and gives the signal to the protecting relay so that it will isolate the faulty section. That is about the circuit breaker. Third one is isolator, or it is also called as disconnect switch. An isolator is a mechanical switch used to disconnect a part of the electrical system for maintenance or repair. So the name says that isolates. It is disconnects from whatever the fault occurs in a section, or for repair or any fault. Then it separates or discloses or disconnects the part of the electrical system. It operates only when there is no current load current flowing through the circuit. Unlike circuit breaker, isolators do not have arc quenching capability. So whatever the circuit breaker that is having, it do not have the arc quenching capability. It only isolates the healthy and unhealthy part of the system. But it operates only when there is no load current flowing through the circuit. During no load condition only, it will operate. That is a function of the isolate. Fourth one is bus bar. So already we discussed about the bus bar. A bus bar is a thick conductor made up of copper or aluminum, which is used to collect and distribute electric power within a substation. It acts as a common connection point for incoming and outgoing feeders. Bus bars are supported on isolate insulators and designed to carry high current safety. Means the main function of the bus bar is it is just act as a common voltage point. All the incoming and outgoing lines are connected to the bus bar, which carries the same voltage level. So it is a conductor, so which generally made up of copper or aluminum. Current transformer. So current transformer is an instrument transformer which is used to measure high current safely. Okay. So it reduces the large current values to smaller standardized values suitable for measuring meters and relays. So current transformers measures the currents. So large currents are difficult to measure. So that we are using the current transformers. It provides electrical isolation between high voltage circuits and measuring instruments. They are essential for production systems because relays depends on accurate current measurements to detect faults. So this is about the current transformer. Next, sixth one is potential transformer or voltage transformer. A potential transformer or voltage transformer generally used for measure the high voltage safely. It step down high voltage to a lower standardized value, typically around 100 110 volts per meters and protecting relays. It also isolation between high voltage systems and low voltage measuring devices. So this is about the potential transformer or potential current transfer, sorry, voltage transfer. Next, last one we are using is lightning arrestor. So we know that air insulated substations are directly exposed to the atmosphere or directly exposed to the environment. So if any such or lightning occurs, it may cause damage to the equipment. So a lightning arrestor protects substation equipment from high voltage surges caused by lightning strokes or switching operators. It is connected between the line and the ground. So during normal conditions, it does not carry current. When a surge occurs, it provides a very low resistance path so that it diverts the excess voltage safely away from the equipment, not to cause any damage to the equipment. That is the main function of lightning arrestor. Generally, in air insulated substations, it is exposed to the environment. So, during any lightning strokes, it may cause damage to the equipment. So, lightning arrestors are act as a low current path or low resistance path to divert the excess voltage safely away from the equipment. This is the main components of equipment that we are using in substation.